So, Sergei and Maxim, I'm going to try to answer your question with a video. So here's a rhombus. I just implemented it. It's one of my shapes now here on the left. And I'm injecting a stream of rays, so 1, 2, 3, 4, into this rhombus from below. And what I can do here is I can change the injection position. And you can see here that the rhombus is perfectly upright vertical, right? I'm not drawing its axis of symmetry, but it's a perfectly symmetric shape. So I can do this, and over all injection locations here, I get this 4 periodic. Now what I can do here simply is either change the aspect ratio of the rhombus to see if anything changes. Of course, it's not going to change when everything is perfectly vertical. Or I can change the angle of the shape, and then I get some phenomena. So I'm going to take the number of rays all the way to 100. Okay, so you can see here that I've slightly changed my rhombus angle from, say, upright at 90 degrees to 95 degrees, for example. And then I'm getting a limit cycle here in the middle. But as I move x0 around, right, I can change the behavior of this limit cycle. Sergei had asked about an n periodic. I'm not seeing an n periodic. What I'm seeing here is that wherever the entry point is, I'm always converging rapidly to this limit cycle shown here. What else can I do? I can perhaps change the angle to 100 to see if anything changes. Again, I have that limit cycle, not noticing any particular periodic behavior, so it doesn't look like we're going to get anything like this. If I change the aspect ratio of these shapes, let's see if there's anything here. Looks like I'm always ending at that limit cycle object. I don't see a horizontal ray coming back into this green area here that would corroborate some sort of n periodic. Let's go to 105. Still not working as I change this guy here. So I cannot escape that limit cycle that gets formed in the middle. I can make it be less convergent by perhaps playing a little bit with the aspect ratio of this symmetric rhombus. Now let's go ahead and now play with the skew of this guy. So what do I mean by skew? I mean, if I go back to, say, 0 here, I have this other control here that can make this guy slightly asymmetric. But I can apply this sort of skew that turns it into, I guess, a parallelogram. So let's see what I get out of that. So let's apply a skew of whatever, 0.5. Okay, and I'm going to apply rays into this. Now I'm still getting what looks to be an attractor in the middle, right? So this limit cycle attractor. It doesn't look like anything periodic is ever forming. Okay, now let's place the rhombus at, well, let's first of all visit the other side. Let's visit the other side here if I can. I guess this guy has to be at 0. Let's see if I can recover from that. I hope I can. Okay, I've recovered from it. So let's investigate this side here of the family. Again, I have that strong attractor. If I jump to the other side, I continue with the strong attractor in the middle. Let's change the angle a little bit. Oh, there's something there. Okay, so when I look at something like this, this could corroborate an n periodic, but then again, it might not. Okay. Okay, so in this configuration, I have this sort of collapse of the trajectory towards a vertex. If I move so all over positions of this entry ray here, I'm getting the same behavior. Okay, now if I turn theta a little more, let's turn theta like so. Okay, so now I'm exposed to the upright rhombus, like so. And let's move x0 around. Oops, looks like it got stuck here. It's going to recover. Again, I'm getting the limiting cycle. Okay, so this limiting cycle is very strong. It's pervasive, seems to be pervasive. Regardless of the skew, right, I get this sort of behavior. And regardless of the aspect ratio A, and in a way, if I play with the angle, the most I can get Okay, let's see if I can organize rays here. Let's play with this angle slowly. Let's see what we're getting here. So we're getting, yes, there we have it. So here's our first example of how many rays are there here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this looks to be like a 10 periodic, but now this shape no longer has an axis of symmetry. Okay, if I move around a bit more and escape this limit. So here's another thing that looks interesting right here in the middle. Let's see if this could be an N periodic. This is the same one. Let's move it to the side a bit more. Chances are we're gonna find something again with this kind of a pattern. So let's place it down here. I don't see anything simple coming out of this, just visually. Let's see if I can find something simple by changing either the skew. There you go, here's another one. Okay, so now let's try to adjust this. This looks similar to the thing that we just saw before. Looks like a good pattern, which probably means there's going to be other ones, maybe simpler ones. Let's see here. Yeah, here's one. Yeah, I'm not going to trust this one for now. Let's see if we find something more telltale. Yeah, so not here. We need to go towards. Yeah, here's an N periodic of sorts. Let's get closer to this guy. Yeah, so no, I'm not coming back. It doesn't look like I'm coming back. So this is a limit cycle, right? So if I reduce the number of rays, I'm getting into a limit cycle here in the middle, not periodic, okay? So yeah, so this exploration has produced one useful result so far. Yeah, so you don't want to be on this zone. You actually want to be on this zone, and you probably want a bigger object here. I can play with that until I get to something like that. There you go, there's one there. Okay, so this one is interesting. Let's try to zero in on it. There you go. So that's a simpler 1, 2, 3, 4, 5, 6 periodic. Okay, so I hope this gives us some intuition as to what might be happening with a perfectly symmetric rhombus and the asymmetric parallelogram.